Well, so it'll pop up.
I mean, it's like talk shit or anything. Or like,
It pops up and then disappears on that.
So you saw when I typed do it. I'm gonna hate myself a little bit more tonight.
I have one class.
Here?
Well, I went into calculus based physics too, and I thought that was my last class for this degree, and they were like, "Oh, you need to take calculus
That's actually
too."
meant you're taking another. You have another class.
No.
after
No,
this class.
I mean, like
That's what I thought you meant, Joe. I was like, how long are you here till?
Okay, so the today's lesson is basically about where some of this stuff is actually used.
That's it.
Okay. We're going to look at some economic stuff with consumer surplus. We're going to look at some stuff, a problem through biology and some population stuff. We're going to look at centers of mass, and we're going to look at probability, or sorry, actually really statistics. We're going to look at the normal distribution curve. So basically, this is where some of this calculus and stuff that you're using in the formulas and with the integration is actually used outside of a calculus class. So it's the one time to say this is where you're actually going to use it. Well, depending on what you're going to do. Honestly, I can't remember if I said it in this class or my other class. It's like the vast majority of stuff, the field figures out ways to do it without actually having to know the math. Because most people don't really like math. So they need to figure out ways to do their job without having to know all this extra stuff. And computers and technology is definitely making that a lot easier nowadays. So absolutely, like it definitely makes it easier. However, depending on where you go in these fields, depending on what you're planning to do, like understanding the underlying stuff is actually very important. I can tell you from an education standpoint, especially in like math education, the fact that the elementary school teachers and even some of the middle school, like the lower middle school teachers, the ones that just have regular like elementary and middle school degrees, the reason that they can't explain as much of the higher end maths or where the new stuff in Common Core comes is because they don't have the background on the higher end maths to really understand why they need to know it. So it's like when they teach fractions, it's like, okay, you can do a fraction. Oh, just now use your calculator, which is fine. But then when you have to do long division later on in algebra class, you're screwed because you don't know how to do long division anymore. So it's like they don't understand that connection to be able to really drill that in there so you can fill in those holes later on. So it's the same concept here. It's like these are the reasons why a lot of that other stuff works.
Imagine if they taught us a long division.
All right, so one of them is known as consumer surplus, or basically the amount of money you're leaving on the table is in essence where it comes from. So when you're looking at, if we're just looking at this curve, there's I gave you the formula for it. This is the integral formula that they're doing for it. But in essence, all they're looking for is the area under that curve above a specific point. So they're saying, okay, at this line, how much am I leaving on the table in terms of where I can lower it? So
Excuse me.
all right. So the formula is 0 to whatever value we're looking at in terms of their problem, so what they're currently selling. The P of X is the formula, and the P is the value that I'm starting at that point. So when we do a problem in a second, you'll see what that all means. So the integral is actually pretty simple. It just depends on what the actual function for the curve is. Sometimes those can be actually very complex. Sometimes they can be very simple. Just depends on that demand curve that they're looking at. All right, so here is the first problem. So the demand for a product in dollars is P equals 1200 minus 0.2x minus that. That is the curve for this product. So if what they do in this formula, sorry, it's been a while since I've done economics. What's this one? 1200.
I'm gonna take it over to Phil and tell him what's on my mind. Why can't we do this?
I have to do one thing real quick.
People in that classroom who don't even know how to do percentage tables. It's crazy. I'm like, students, like, I can't do it.
You can't. All right. So we want to figure out the consumer surplus with a sales level is 500. Basically means they want to, if they're selling 500 of these products. Okay. Come on, open up. I'll open up afterwards. So let me actually copy this over. X. X is 500. Because that's the value they're giving. All right. So find out what P is. Well,
Ooh.
no. So that value is going to give you that point. So right there, we're looking for that value. So if X is 500, what's the Y value? Correct. So plug into the formula and find me the Y value. Equation's right there.
My calculator walked away.
So when you plug in 500, you get what? Correct. So that means they're selling 500 products and they're selling it for $1,075.
And that's big P.
Yes, that's the price.
For 500.
You plug it in for X. So for 500, if the sales level is 500, if they're selling 500 of the product, they can sell it for $1,075. If I sell less, so if X is less, my price would be higher. If X is more, my price would be lower. Okay. So depending on how many you're selling, depending on how, like that value, that's where they're leaving that extra money on the table, basically. Okay. So now we can plug into this equation. So we have 0 to 500. P of X is my original equation, so 1200 minus 0.2 X minus 0.0001 X squared minus P, so 1070.
I would agree.
All right. This one's an easy calculation. So 0 to 500. Put the 1,000 and the 1,200 together, you get, what is it, 125? minus 0.2x minus 0.0001x squared dx.
And we can just integrate, right?
And now we just integrate it. So what's the integral?
1.5x minus 0.1x squared minus 0.0001x cubed over 3 with 0 to 500.
And then from 0 to 500. The 0 is going to cancel everything out, so I don't have to worry about that. I just got to plug in the 500. And we get $33,333.
Oh yeah, that kind of number.
That's the consumer surplus.
Which means
So basically, the consumer surplus is the difference between what the consumer is willing to pay and what the consumer actually pays for the product. So remember, basically, if we're looking at the graph, as we sell less, so this is the sales and this is the price. So as we sell less of them, we can sell it for a higher price. So there's people that are willing to spend more money on it, but I would only sell 400 of them. So that's what this piece is. This is the amount of money that people are willing to spend on it, but I'm setting the price here to sell this. I have a certain target sales amount that I need to get. So this is the amount of money that they'd be willing to spend, but they're not spending. Make sense? Again, been a while since I've been in an economics class, like
join us for with Phil.
almost 30 years. So,
Join us with Phil tomorrow 2 p.m.
all right. Oh, sorry. Let's do another one. All right. So here's the demand function for microwave ovens. They gave us the equation, and they're telling me that the sales level of ovens is 45,000. What's the consumer surplus?
Would X be
45,000. Oh, yes. In this case, X would be 45. Yes, because it's measured in thousands. Yes.
If we did it as 45,000, would we still get the quote unquote quote like right answer?
No. It'd be way lower.
Even if you multiplied by or
Yeah,
divided
because
by
you-
1,000 at the very end.
Because in essence, you were plugging in 45 million to X.
I'll divide by a million.
So
Yeah, okay.
Find my answer.
This number. 220.
What's P in this case?
5.5.
225.5?
Yeah.
Okay.
I would go in hundreds or just tens.
It's money, so I do hundreds.
I have 4 then. Yeah.
Oh, okay.
But that's why I asked.
Sorry. I didn't do the problem, so I didn't I was taking your words for it.
I appreciate that you trust us with that much on this. Holy shit, you got it right.
Yep.
Almost not perfect. We're gonna get it. Negative. That one,
What?
and we're gonna get a negative.
I don't know. Shouldn't.
Well, if you plug in 45 to the, the first one, right, after the integration process, it stays the same, right? Because e to the x is e to the x.
You have to do the chain or the U substitution on E. Because it's not just E.
I was like, huh. On just e or e to the x.
Well, you have to do it on the E to the negative 0.03x. Because you have to say negative, you have to do the implied U substitution there.
The implied u sub brings it out front, right?
Yeah.
So it becomes negative 0.03 times 870 e to the x.
Yeah. All right. So, oh, they just left it as that. That's fine. If you put the 225, 45 in there, it wouldn't have been a difference.
Oh, they wrapped it. Okay.
All right. So the one piece, don't forget, like I said, do U substitution for the negative 0.03x. It's not just e to the x. So it does end up staying, but you have something in front. Remember I said that implied you could just basically take whatever's in front of the x there and just divide by that in the front. That's basically what it always comes out to be. So if it was 2x, I would have done 1 divided by 2.
Why do they leave out the P?
They didn't. They just plugged in 45 and actually left it as e to the whatever it was. They didn't do out the actual number. So they plugged 45 in for x, which would be 870 e to the dat. They just left it as the e to the 870 e to the negative 135. They just didn't actually do the number. They left it as a full thing to do the before they did the actual rounding of the calculation. Okay.
Yeah.
Yeah, they just didn't round. So you'll notice that a lot of times in this stuff, they don't round until the very end. Because when you're dealing with larger numbers, depending on how you round, you could lose information that you might need.
Or you're off.
Yeah. So like this stuff isn't that big of a deal. It's like when I worked for the bank, they were happy if they were within $100 when they were doing a bunch of different stuff. It's like, so as long as their balance sheet was within $100 at the end, they were happy with it. Like that's a lot of money.
I was gonna say, yeah, technically.
So this was back in the 90s when they didn't have a ton of stuff to be able to do all the calculations and everything else. I wrote a program that got them down to within a cent. And they were very happy with that. So I actually wrote the program completely in Microsoft Access. No, the president took me out to lunch and everything else. I was very happy. And then they paid me for the Y2K issue because my program was going to take over the bank for Y2K, which didn't happen, but would have happened if we didn't solve all the issues before that came up.
Yeah, because no computers actually had any years after like.
Right. So we solved that issue before that. That's why it didn't happen. So in this case, they're leaving $11,332.78 basically there. People would pay more. Now, if you think about those of you that are in your economics class, it's not just all about consumer surplus and stuff like that, though. You also need to worry about there's that break-even point where you have a certain value that you're selling it for. If you sell it for less than that, you're going to start making less profit. So, or you're going to, you're basically losing money by selling it higher. You're going to make more money per product, but you're losing sales, which you could have had. So you're trying to find that sweet point. This is just another number to help them figure these things out. Yes.
So, you as a manufacturer, you would want to minimize consumer surplus.
Yes. Yeah, you want to minimize it, but you can't ever eliminate it. Because if you, I could technically, if you look at the graph, like if we look at that first graph that we had, I know this is just a simple one, but I could technically sell one thing for $1 million, for example. But I sell one.
If that, right?
So it's like by selling 500 of them, I might make more money, even though I'm leaving money on the table because of that. It's like, that's what I'm saying. You're never going to minimize consumer surplus down to zero.
Oh, so if you can sell more than 500, then
I would lower the price.
the area between two curves flips, and now you're making more, and the customer should theoretically shop for a cheaper alternative.
Yes. Exactly.
It's like the store brands versus like actual brand, like store brand Cinnamon Toast Crunch versus like actual Cinnamon Toast Crunch. It's kind of like that. The store brand's always a little bit cheaper.
All right. We also have, there's two other ones. I'm going to move this over and I'll shrink this down. So the producer surplus. So if you look at the manufacturer is one side.
Will this be on the test?
No.
This
This is one of those. This is one of those lessons that it's just literally here's a bunch of different places you can actually use this stuff. This will not be on the test. Your test will be 8.1, 8.2, and 9.3.
Let me write that down.
It's the three things that are on your actual homework problems.
8.1,
Yeah.
8.2,
Never check to see if the word 6 and 7 flows already.
Oh, okay. 9.3.
See, that's good information.
So the producer surplus takes the supply function, which the only difference is they put the S next to it instead of it's PS, so it's the supply for the price. But it also flips it around. The P goes first, so it's P minus the supply function. So producers are willing to make and sell a commodity for a lower selling price and therefore receiving more than their minimal price. So they could sell it for less, but their goal is to get as much possible money out of the the actual, like, their job is to get more money. So that's why it's the opposite of the consumer surplus. Okay. Consumer surplus, they're like, that's money that they're leaving on the table that the consumer's happy about because otherwise they shop for something that's cheaper. The producer doesn't care about that because the manufacturer is paying them. So again, you're not going to have these on the test. You do not need to memorize these formulas. We're just using them. All right.
That's PS.
Yeah. So this one, where am I putting that 625?
As P.
That's P. Well, it's the P that's there. So it's 625 equals 125 plus 0.02.
So
X
0.02 x squared minus 500 is what we would want our equation to be.
So we got 500 equals 0.002 x squared.
Wait, is this
So divide by the 0.0002, and we get what? Yep. And then we do what? So x equals
50,000?
500. Because 0.002 is 1 over 500, actually.
Well, that makes sense.
All right, so remember my integral for this one?
Minus. Oh,
So my integral is going to be from 0 to 500. The price is 625 minus the 125 plus 0.002 x squared.
it's pretty straightforward.
The only thing like that would this formula never changes. This is literally the production surplus formula for it. The supply curves, the demand curves, those can get more complicated depending on how market forces work. They're not always just exponential curves or parabolic curves and stuff like this. They're not always like that. So that can change. So you should get $166,666.67. What? 0.002? It would be 2 over 1,000, which reduces because it's 2,000s.
You're right.
All right. A hot, wet summer is causing mosquitoes to explode. The number of mosquitoes is increasing at an estimated rate of 2,200 plus 10 to the e to the 0.8 t per week. By how much does the mosquito population increase between the 5th and the 9th weeks of summer?
Why?
Not quite.
Kind of equation is this? Or correction, what kind of integrate? Is it a consumer surplus or a?
This is not either one of those.
This is a new thing.
This is a new thing. But what does an interval give us? Area under the curve. So if we look at this function, we graph it, we'll show the graph. Plus. Zero weeks to 10 weeks. 10 to 0 to
Also, if you put a population rate, you'll get a population number by doing an integration.
so this problem is telling me the estimated rate it's increasing, right? Which would be the slope, because rates are slope, right? So that is the derivative of my population. So if I take the integral of my derivative, I get my original population numbers. So for this problem, all they're doing is taking the integral of this from the 5th to the 9th week. Because sometimes it's easier to figure out how things are increased, the rate things are increasing than the actual total population of it, because you can do sampling of that.
So this is how they find the population of the world.
Yeah, actually.
I was gonna say it's probably hard to keep track of all those kids get popped up around.
What a lot of times what they're doing is they're using sampling. So they will go into a lake or an area and they'll capture a number of mosquitoes, and they'll count the number of mosquitoes. A week later, they'll do the same thing. They'll count the number of mosquitoes. The change in that is now the rate of change. Because they do sampling at a bunch of different areas, they can get a good idea of what the rate of change is,
Average it, right?
and then they just figure out a curve based on that information. They might not be able to figure out the exact population because they can't mark a mosquito. They do that actually with fish. If they're in a lake, what they do is they catch a bunch of fish and they mark them. So they're going to catch 100 fish, they're going to mark 100 fish. They throw the fish back in the lake. The next week or so they go back and they catch the fish again. They count the number of fish they marked compared to the number of fish they did that come up with not marked, and they can use that to estimate the actual population in the lake. That's why they tag things. So that's easier to do on that than mosquitoes. Can't really tag a mosquito.
It's probably quite weird.
But that's pretty easy. You just put out the light thing in those tracks, and then you count they're dead. You're not counting them alive. So in this case, all we're looking for is the integral of that. That's the thing. It's like when you start to look at where, like how we can start to do some of this stuff, it's not always this massively complicated formula. Integration allows us to do a lot of things like this. And they use it quite often. You just don't see it. Like I tell people all the time, it's like, you use math a lot more than you think you do. No, none of you are wandering around using integration on a daily basis. But you're impacted by it. And that's the thing. The stuff that they use these calculations and stuff for does impact what you do. As you just saw with pricing, they use that type of stuff to figure out how much to charge you. We're all complaining about how much prices cost, how expensive things are. Shit, I went to McDonald's, I paid $18 for my meal today.
That's a damn lie, and I know it is. I worked there.
No, seriously, it was.
No, that's true.
Did you get a large double quarter pounder meal?
Yes, exactly,
Yeah,
actually.
that's what you worked at.
But I used to pay $10 for it.
It's true.
So the question is, I was like, okay, so the prices are high because they can increase them. People are still buying them. The only way for it to go down, as we just saw,
Well, stop buying.
right, the demand has to drop. If people aren't buying them at that price, they will start to lower the price. There was a whole big controversy that just came out about Wendy's talking about surge pricing.
Oh,
Like
yeah.
that was a big deal.
Yeah, people were-
That concept works because as demand goes up, people are willing to pay more for a constricted supply. If you only have so much you can sell, if you raise the price, you're still going to sell a certain amount of them and you're going to make more money. That's why Uber and Lyft does it. When they don't have as many drivers around, they raise the price. So you're going to pay more because the supply isn't there. Okay. And that they use the prices to lower demands, basically. Yes.
Aren't prices that are sticky that go up
There are some. Oh, absolutely.
rent?
Yes. There absolutely is some things that, like, once it goes up, it's not impacted by supply and demand. There's other forces that are involved in that. And that's
What's the
rent
McDonald's
is
did you go to?
up in Hartford.
Yeah, but
A double quarter
Like
pounder
rent's one of
pounder.
those. There's other forces outside of that. Gas is another one, actually, that it's not totally set on supply and demand. There's a lot of other market forces that impact that. That's why we saw back when COVID happened, the price of gas dropped because demand dropped off the face of the earth. Nobody was driving. So that's why gas prices were down in like under $2. Okay.
It was
When
very
COVID
nice.
stopped, when people started going back to work, supply didn't go up because they couldn't raise the supply that fast. That's why gas prices jumped quite a bit because the demand rose up. So it's like those type of things. But then there's the actual market forces where, like, the price of oil and stuff like that does impact gas as well.
COVID was a
There's
great
lots of
time
that
to
type of
drive,
stuff.
actually.
So, but yes, there's some things that go up and they just never go down. Unfortunately, that's a horrible thing because rent's typically locked in for a year. You're stuck. You got that. That's it. That's what you're paying. They don't change things as time goes on. Taxes never seem to go down either. Actually, it's funny. I've seen that change.
Me too. I've seen it in
Some places. Yeah.
Well, part of it's inflation, right?
Well, yeah. The more money in there's more money in the actual, like, there's more money supply, so some prices do go up from that. But there's a lot of reasons for it. But in the end, supply and demand really does impact a ton of it.
So we just all stop paying
If
taxes.
people stop, that's never going to change. They'll just come after you. If people stop buying things, like you brought up the brand name products,
Yeah.
and generic products. There's certain products that are cheaper to buy in generic, and they're the exact same thing. It doesn't really matter. So people are going to buy those products over the name brand to save money. Yeah. So it's like there's always little things that change. Some of them are literally made on the same lines. It's literally the boxing and the advertising budgets. Yes.
Look outside that window. Is that one big spider web?
I can't even see a spider web.
Yeah, what do
See
you
it
see?
around the light?
No.
That's a tree.
Oh, that's a tree.
I could say that looks like a.
So like annually, you should always see your.
Yeah. Yeah, maybe it's time for eye
Like an
doctor
annual
appointment.
thing.
It's all right.
All right. How many of you have bought something?
And like, how
Can you be
long?
more specific?
No, you've never bought. No, how many of you have bought something and it dies right after the warranty goes out?
That's how products are made now. That's how they're made. What?
So there's a reason for that. It's all based on probability and statistics, which is the next thing we're going to look at. So they know that they do a sampling of the products to figure out exactly how long something's going to last. And they know that a certain number of products are going to fail before this time. A certain number of products are going to fail before this time. They then pick a number that's based on how many products they want to be able to fix compared to what they don't want to fix. So, because if it dies within the warranty, they're going to have to replace it or do something else for that. So that number, there's a whole bunch of data that goes into figuring that number out. So when everything is like, why does this always die after warranty? It's designed that way. It is going to fail soon after that piece because they figured out where that number actually is. And technology has allowed them to figure that number out even more accurately. That's why you're seeing it happen more often now than before.
And then
Unfortunately.
there's like certain clauses with like within very certain warranties, like some car warranties.
Oh, there's
If you don't like see the dealership with your car like every 6 months,
Yeah.
your warranty's just gone.
yeah, there's a whole bunch of crap for that. All right. A lot of that has to do around the bell curve, the normal distribution.
Yeah.
So, has anybody in here taken statistics?
Oh, not statistics, but we did a bunch of bell
Yeah.
stuff.
So, all right, if you've taken statistics, all those things that they taught you in statistics, you can now do with calculus and get it a lot more accurate. So in statistics, when I teach it, we teach the rule, the empirical rule, 68% for one standard deviation, 95 for two, 99.7 for three. This formula is what gives them that information. So what that integral does is it creates the area under that curve given two pieces of information, the mean of the data and the standard deviation of the data. Because as you can see, as the standard deviation changes, the curve changes.
That's a good one to know.
Okay. This formula you will never be able to do out by hand. You have to use a computer to
But if I
calculate.
were to take a statistics class, could I just use this in that class and
Yeah.
get away with it the entire
Well, no, because your teacher's probably going to want you to actually write out to show how you're getting the information.
Well, I mean, I'll just write down that. And they'll be like, I
already
didn't know
been
this.
shown how to solve.
You can't solve this. It doesn't actually have a elementary solution.
Hell yeah, like number 5.
You can get a number. You can do it using like Simpson's rule and stuff like that to actually get a numerical approximation of it. But what I'm saying is you're not going to be able to just take the integral of that and get an actual like equation out at the end that you can then plug a number in afterwards, like we did for these, where we've actually plugged numbers in and got an answer. So because of the way that it actually is calculated. Yeah. Go ahead.
Oh, so the limits of integration here,
Is negative infinity to infinity.
yeah, so like what is that? What are those people? What is that?
No, it's literally it depends on, in this situation where we're talking about IQ, yes. Yeah. So in essence, the bell curve goes on forever and never touches 0. So it's pretty much known that I think the highest IQ that's been recorded is like 209 or something like that. But technically, based on the way standard deviation works and the bell curve works, somebody could have 1,000 IQ.
I'm 5.
The chances of it happening is next to none. But since it goes out to infinity and never gets to 0, there's a chance that could happen.
Okay, so the limits of integration are IQ score.
Yeah.
Okay.
Yeah.
Not people.
Not people, no, the IQ score.
So is it essentially
The actual the actual space under the curve, the area under the curve is the number of the percent that would translate into people.
is the reason why it never touches 0 the same reason as like infinite monkeys, infinite typewriters? infinite
Yes,
time-
yeah, it can always happen. It's just not likely to happen.
7 has 7 IQ.
Okay, it's just not likely to happen. So for this one, I have my mean, so is 500 or is 100, and my standard deviation is 15.
Oh, that's 6.
Oh, that's what that's in there.
That little
It's like a.
it's lowercase sigma. Yeah. And that's the lowercase mu. They're Greek letters.
Just sideways 9.
That one we got.
Huh?
The lowercase u.
No, lowercase mu.
Oh, I think it's you.
No, mu.
What is you?
It's a Greek letter.
Every problem.
They're both Greek letters. It looks like a U, it's not.
Mu.
It's mu. That would be a U.
I'm not gonna use like you.
All right, so they want the first one was from between 85 and 115. So we do 85 and 115. For those of you who took statistics, that's one standard deviation. So the number should be approximately 68%. All right, so plug our numbers in. So it's 1 over 15 square root of 2 pi e to the negative x minus 100
So it's mu.
squared. Yes,
Sorry.
that's okay. I'm just going to finish writing.
I did 15.
They give you 2 right here. And also for IQ, these are the standardized numbers. An average IQ is 100 and the standard deviation is 15.
How does it sound with IQ test? They kind of right.
Huh? Yeah,
I think-
100 is average.
I thought 96 was the American average.
Well, it might be. But 100 is average. And this is why, like, everybody's goes, if you ask anybody their
What
IQ
was
score,
Forrest Gump, like 60?
70 so the American the standard for intellectually disabled is 70. So because it's 2 standard deviations, it's about 2.5% of the population is below 70 IQ.
There
Which
a-
are considered
a
intellectually disabled.
standardized test
Yeah.
to measure?
Yeah.
There's a few.
Yeah, you just go to
If I wanted to get government assistance and I needed to prove that I was disabled, would I have to take that test?
most times if you're going to go to a psychiatrist or a psychologist and actually go through
Oh,
the they actually would do those testings. Yeah, and they would do those testing.
So like if you go online and Google IQ test, that should
No.
say-
I had my
None of those are accurate. That's why I said if you ask anybody their IQ score, they're going to give you a number between 120 and 160 or so every single time. Okay.
Even if they don't know.
Like even if they don't know, they're going to give you those numbers. because
Einstein was like one-
everybody has to be better than average. But 50% of the people are below 100. 50% of people are above 100. All right, it's the way it works. So that's just the way it works.
But at the end of the day, like your IQ doesn't exactly. It can prevent you from doing like super high level things, but if you sit there and work at it, you're still gonna.
Yeah, IQ doesn't like we've gotten
not the
past the
end-all,
point of
be-all.
IQ basically being
It's
the
an arcade.
the end all be all of
like it helps.
intelligence.
Like it's not gonna
So
be the reason that you don't get a job.
it pretty much is. It's a brag point at most places. Huh? No. It's not that type of test to study for.
Like
It's not like a SAT school test.
So like they might put patterns in front of you and see how quickly like you can pick up that pattern.
Right. It's about time. There's a lot of stuff to it. It's not something again that you can just study for it. All right. So this one, if you notice, like the beginning number there. Okay. So here, I'll show you why you can't do this. Because I think that's a good thing to see. All right, so we've got this. So the first big part, this whole piece we can pull out. Because that's literally just a constant. So now we have E to the negative. X minus 100 squared, square that out. So you get x squared minus 200x plus 10,000. All over 2 times 225, which is 450.
Quick math. And we'll split up the fraction.
You can't do that. I can't make that u because I don't have an x anywhere else in the problem to do. Okay. There's no value to be able to pull out. So that's why you can't actually solve it with all the methods and stuff that we have now. Most situations, you just literally do this out on numerically, usually like the Simpsons rule or some other computerized technology way to actually do the integration out, which is what I'm going to do right now. So let me type it into Desmos and I'll show you how it actually goes into Desmos. Oh yeah, there is ways to do non-elementary stuff. It's just way above what anybody is going to actually have to do unless you're literally going on to theoretical mathematics. So,
God damn it, man. Why you gotta do that?
all right, so
I'm thinking about astrophysics. So
The highest level of math you think is what?
well,
you can get you can get your doctorate in mathematics, where you're creating your own mathematics, basically.
yeah.
All right, so here is
My brother said that's some good
there's the equation.
for-
Hope it's never come out to be 0.682 or 3, so just about 68%.
How do you know?
So,
It was like 2 pages. There's an equation and then massive.
Off the top.
Because the empirical were for statistics. So when you teach or learn statistics, you don't learn this formula. You learn the empirical rule, which is 68, 95, 99.7. That's the standardized thing that they use to do all the breakdowns. 1 standard deviation, 2 standard deviations, 3 standard deviations. So 2 standard deviations would be double the 15. So it'd be from 70 to 130, which is approximately 95%.
What if it's like
So we were talking about below 70 is intellectually disabled, right? So all we would do is we change this from 70 to 0. So you're approximately 2.2% of the population or 2.3% of the population
what about 0 to
would be
15?
considered intellectually disabled.
What about 0 to 15?
So, well, 55 would be, or 55 would be 3 standard deviations, and now you're less than 1%.
Less than 1% true.
Okay. So you could also go the other direction. So if we did 140 to, I don't think you can actually do infinity on here. So just pick a high number.
Still be like, still less than 1%.
Right. So 140 and above is almost the same as 55 and below. All right.
So like everybody's sitting between what, 100, 140?
The vast majority of people are between, well, 99.7% of the people are between 55 and 145.
Wait, 55 IQ?
Yeah, and 145. That is
You said
Clearly,
70, so it's
everybody
actually
here has
safe.
high
Right.
IQ.
So what is 55?
55 is below that. So if you're looking at 70 to 145, you can do that. That's one of the nice things about Desmos. You can actually just play around with numbers. So 97.6% of the people are between 70 and 145. I believe Mensa is 155. If I remember right.
So it's
The official high IQ group.
So stupid. It's such a waste of fucking space.
Wait,
So
that's the thing.
no.
It's just a big circle jerk.
So
What's the point of even being in it?
it's
Exactly.
Oh, you're so big brain.
exactly. It's like it's just
Do something useful.
it's just to
It's
say
like,
you
I'm
did
a
it.
smart cookie, guys.
All right. So that is one place that actually this is used.
Oh, yeah.
All right. Here's another one. Actually. All right. Set up my integral for this one.
I don't know if I want to.
The integral is going to be the same integral. You're just plugging the different numbers into it. While you do that, I will find the other piece of information I want.
What perspective is it?
This one.
How do we find the percent?
You have to plug it into Desmos to use the integral. What is my mean?
268.
What's my standard deviation? And then, so my range, my integral for this one's from 250 to 280. So it's 1 over, what was it? So that's your formula. 250. All right, how many months is 200 and, oh, 280?
68%.
about 68%. So how many months is 250 days?
So, wait,
Yeah, like 8 and some change.
Mhm.
More than 6 months.
More than 6 months. Yes, definitely more than 6 months. How many months is 280 days?
really less.
So it's a little more over 9 months. So about 67% of the pregnancies will be between those values.
Those aren't good odds for like planning.
No.
That is true. Like, that's
No,
horrible.
it's not.
odds.
But that's why, like, so 9 months, how many days? Exactly 9 months.
Assume 30.
269.
Assume 30.
273.75.
Damn. That's kind of suck. You had to carry a 13.
And then let's do 10 months.
Like, imagine you're
304.
Suck.
So a third of all pregnancies will last more than 9 months.
It's gotta be 10 though, because the other half, right? They have to do 250, right?
Well, I did this at 9 months. This is 9 months. So we'll do 274 because it's easier. That's 9 months to 10 months.
Um,
So a third of pregnancies will last more than 9 months, which we would consider to be the norm.
overweight.
So yeah,
Is that like a perfect bell curve?
Yeah.
But like that's not how it is in real life.
yeah, it is.
Well, no, some,
So, like-
some babies do get pregnant for 268 days.
That's an outlier, and you don't care
But
about
if
that. You know, just-
68% happen around 9 months, and then about a third happen the month after at 10 months.
Right.
That means that doesn't leave many 33 plus 60. That doesn't leave much.
It'd be like a third happening in 8 months, a third happening in 9 months.
I thought you just said a third would happen like,
Between 9 and 10 months.
so like yes, between 9 and 10, a third
Yeah.
will happen then.
Yes.
And then 66-ish, 68% will happen at 9 months.
No, not exactly 9 months.
Oh,
It's probability or these type of things is never one specific number. It's a range. So this is
yeah,
looking
so-
from
so
9 to 10 months.
Whatever it is at 10 months, it's going to be equal at 8 months. Right?
From 9 to 10 months is not going to be exactly equal from 9 to 8 months because 9 months. So there, if we looked at this, when we looked at the numbers, 268 days is not exactly 9 months. It's a little less than 9 months. So your mean is not exactly 9 months. Although if you ask anybody how long it takes for a human to give birth, they're going to tell you 9 months. They're not going to tell you 268 days. Okay. So that's where that range comes in. So in statistics, once you get past a certain number of values, everything pretty much falls into that bell curve, which allows us to do a lot of those calculations. Even if we think it's crazy, it falls into that bell curve.
Sorry,
Yeah, go ahead.
this equation, you just used it previously for IQ and now we're using it for pregnancy.
Because that equation's not for IQ. The equation is for the curve.
Oh. But like that's not how it is in real life.
Yeah.
Well, in real life, you have factors like nutrition.
So, right, but the bell curve takes all those into account. So you're going to have those situations where you're going to have somebody on the
But, like,
low
bell
end. You're going to,
curve so this is a global bell
yes,
curve.
this or United States bell curve or whatever else you want to look at it. It's that's the curve. So
But a bell curve for the United States would be different for a bell curve for Haiti.
no, the mean would be different. And the standard deviation could be different. The bell curve is still the same. The actual formula for the bell curve is the same. What changes is those two numbers, the standard deviation and the mean. That would be different. And actually, that's going to lead right into the next question I was going to give you. So I will show you what changes. All right. So here is
70 inches is
3 inches is crazy.
The average height of a man in the United States is 70 inches.
5'10",
You want to tell me how tall that door is?
probably like
Exactly, actually. Huh?
Yeah.
For gymnasiums too, is part of it.
Exactly.
I'm like 6'8".
It is. It's 80 inches. That-
And
that-
so it counts
I-
99% of people.
Why is it 80 inches? Why is it 80 inches?
I can answer. It's the 3 standard deviations above.
So let's look at it.
Ergonomics.
Kind of.
That's right, like,
All right. So we've got
that's
this. Here's my information, right? So let's make my curve for this. So my curve will be 1 over, my standard deviation in this case is 3, square root of 2 pi, e to the minus x minus 70 squared over 2 times 3 squared. That's my curve. That is not the integral, that's the curve. Three 70 was it 2 times 3 squared. All right, sorry, I'm just setting up something in Desmos so you can see this. All right.
Would you have to do 2 different integrations for the 2 different populations?
Yeah.
Wait.
And it's not working. Why is it not working? Oh, because it's way over there. That's why. All right. I'm like, why is my bell curve not working? Because it's not at 0. That's why.
Hell yeah.
So let's do 40 inch or 48 inches. That sounds about right. To 96 inches. All right. So here is my bell curve.
Hell yeah.
Okay. So the integral is going to give me the area underneath that curve, right? The area underneath that curve is going to be the percentage of our population that meets that criteria.
It's like 21,000.
Okay. So when we're looking at let's see if I can just do this.
Might have to make it after that.
Yeah, I'll just copy the formula.
Okay, you might just need parentheses there.
That works there. All right. So what this is giving me is this is telling me the population or the percentage of population that is under 80 inches tall for males.
So basically you're saying 99.
9.99957% will fit through that door. That is why it's 80 inches.
Now think about the NBA. You gotta be like that tall. or-
So, because if we changed it, if we did 7.5 or 6.5 feet, so it would be 78. So we're getting closer to 1 out of every 100 that would bump their head in the door
Can you?
instead of 1 out of every 1,000. If you did 72, that's 6 feet tall. Only 74% of the people would be able to fit through the door, which is still the majority of the population. But do you really want 25% of the people have to duck to get through the door? So they've picked that number in the United States. Anybody know what the tallest country in the world is? It is Norway.
Yeah, some. What?
So in Norway, the average is 6 feet tall. So my standard deviation, so my curve that I have, this changes to 72 inches because it's 6 feet tall. And hold on, I gotta change centimeters to inches. About 3 actually. It's still about 3 inches. So that changes. So my curve, my bell curve doesn't change. It shifts. And actually, the official standard deviation is 2.73, so it's a little wider. And if we found the same thing, if we looked at this one again, but we did it up to 80 inches, but we used this curve instead, more people would hit their head. So the doors in Norway are actually a little taller.
Yeah, like, well, 1 inch, 2 inch,
Yeah, they'd probably go up a couple inches.
less than
Okay.
9.
Yeah, if we did it to 90 or 82, now we're back to about where we were for the United States.
Like, this door, please.
Okay. So yeah,
How does it? Maybe I'm not thinking it right. So my immediate question is, how does it know that, like,
lots of math. Statistics. So there's a ton of math and research behind the normal bell curve. That's why there's a whole class basically around it.
is there ever a situation where a bell curve is not symmetrical?
No, bell curve by definition is always symmetrical. Is there situations where the bell curve, curve can be skewed in certain situations? Yes. So there are situations where the actual curve is not a bell curve. It's skewed to the right or skewed to the left, or it can literally have multimodals and situations like that. That the curve, that the actual data is not normalized, which is why this is called the normal bell curve. So if the data is not normalized, it wouldn't fall under this bell curve, and we wouldn't be able to do all this other stuff. However, there's a ton of research and everything else done through statistics that basically shows that once you get over a certain number, and actually the number is pretty small, it's like in the 30 to 50 range. Once you get past that, most data actually falls into that bell curve as long as the data is collected correctly. So if I just looked at the people in this room and took all your heights and said, got that, and took maybe another room and took all their heights, I'm not going to get a bell curve out of it because the data wasn't collected and randomized.
You can do it across.
If I did it across the whole state and randomly selected 100 people across, I would get normalized data. So that's how this all falls into place. But you can start to see how this stuff really does impact how doors are made. Like your job is completely impacted on this. Like everything about ergonomics is designed around
Basketball.
Yeah. all that stuff.
Volleyball systems come from the sky.
So it's like all that stuff is
That's what I do.
designed around these numbers.
What if? I'm just trying to construct a situation in which. What if you took a bunch of people from Norway?
Yeah.
And then you took a bunch of people from the Philippines, and then put them in a stadium, and then you took their heights. Wouldn't it be like skewed at the
Correct,
ends?
but that wouldn't be normal. So the question is when you're looking at this type of stuff, you have to figure out what is the question you're trying to answer. Are you trying to answer the average height in the stadium? Or are you trying to answer the average height in the world? If you're trying to answer the average height in the world, you've collected your data incorrectly because you have to collect data from all over the world. And it's got to be randomized data from the world. So you can't just pick 100 people from Norway, 100 people from the Philippines and say it's
Average height in the
randomized.
Stadium, it wouldn't be one hump, it'd be two humps.
Yes.
right?
Absolutely in that situation.
But
Because
that's not, you wouldn't call that a bell curve.
no, because it also isn't.
Yeah.
It wouldn't be statistically randomized data. That wouldn't be good data in this situation, and that's why when you're looking at information, and this is why people say you can lie with statistics, because depending on how you collect your information, depending on how you get your information, will really impact what your results are from that information. So 2016 is a entirely perfect example of what happens. What happened in 2016? What was the main thing that happened in 2016?
Like November of 2016.
Yeah. Okay.
Yeah.
So everybody, up until literally they announced it, believed Hillary Clinton had won. Because all of the data that they had collected for months showed that Hillary Clinton was going to win. It was bad data. But everything was based on that. The bad data happened to come in, and what they've done research after that point is people lie. So when pollsters call people, they get information. That's how they get their information. They call people. Okay, if you do an internet survey, that's not randomized data. You cannot use that data. You have to randomly call people. This is why I always tell my statistics classes, if somebody randomly calls you and asks you wants to do a survey, answer the survey. Because the people who are answering those surveys are the bored people that are sitting at home, and most of them are older. Okay, their data is going to skew a lot older. What they found in 2016 is people lie. There was quite a few people who, well, it was, believe it or not, it was the first time that it really came up, because people did not want to tell somebody else that they were going to vote for Trump. They were going to, but they didn't want to tell the media that. They didn't want to tell the man that. So they didn't. They said they were going to vote for Hillary. They said they were going to vote for somebody else, or they didn't answer the question. And what happened is it skewed the data. It had false data in it. So that's why all the polls said one thing was going to happen and the opposite thing happened. Was for that reason.
What they do to correct it since.
So they actually, what they've started to do is they're asking questions differently, and they're asking questions in different manners to figure out, to basically get that, to eliminate that population of the false data.
So they're still calling.
Oh, they're still calling people, absolutely. That's actually, as crazy as it sounds, it's one of the only ways to actually get good
Doesn't that,
data.
like, automatically skew the data? Because old people are more likely to.
Absolutely.
Time
Absolutely. Which is why I say when somebody calls you to ask you a survey, answer the phone and answer the survey. Because unfortunately, the younger generation doesn't do that, and it does skew a lot older.
Shouldn't they come up with a better?
Don't
put it on the younger generation.
Yeah, unless I know the number, I'm not picking
I-
it up.
I know.
More or less like an 8-6 over.
Anybody asking me anything?
So,
anything,
The problem with answering, or the problem with basically doing any kind of survey where you're asking people to give you information, just anybody to give you that information, is that it tends to skew the results one direction or another. So if you put a poll out on Facebook and ask a question, like who's going to win the president? This is a great example. This was in 2020, actually. Politics seems to come up a lot in this.
You're
Is-
already skewed. You're asking me on Facebook.
Well, honestly, absolutely. But if you're asking in any of the social media platforms, what ends up happening is you will get it shared by certain groups that will bomb the survey to fill it out. So, for example, there was a survey on Twitter at the time that said Joe Jorgensen was going to win the election. 75% of the people who completed the surveys voted for her. She got 2% of the vote. She was a libertarian candidate because it was shared in a bunch of libertarian groups, and everybody went to fill it out to get that name up there. So that's what ends up happening. And you will only see things on any of the social media platforms because it uses your data to figure out things that you would enjoy or things that are going to make you happy, because that keeps you there. That's why if you start putting the angry emoji on or angry reaction on things, those things will start disappearing from your feed.
Yeah.
And you'll get a feed that makes you happy, that makes you want to stay there. But you're only going to get the side that you want to see, which is how we become this polarized country. Yes.
So theoretically, right, if like, they say they kept calling in, like, you know how they do about the president election?
Yeah.
That would get the old people's opinion, right?
Yep.
And then theoretically, let's say you posted something on, you know, Instagram, Twitter,
Yeah.
Facebook, whatever, you know, and it was like, it was via Instagram, like itself. They showed it to everybody. It doesn't matter if your feed is political or not. As soon as you just log in one day and it says, hey, if you're comfortable, who did you vote for? And then, you know, some people are going to click who they voted for.
So
You average those and figure it out.
So who you voted for is easier to get than who you're going to vote for. Because, and this is actually what, if you watch the elections after it happens, even tonight, there's like 15 states voting in the primaries, which literally mean absolutely nothing this year. But they'll start calling those things beforehand because they have exit polls. They literally have people that go to the polling stations and ask random people questions. And based on that, after the fact, they can figure out who's like why people voted a certain way and a lot of all those other things. So afterwards is a lot easier to do than beforehand.
By random, could you say every other person? Or was that considered not random? anymore?
You have to do every other person in every event, every area. That's the thing. It's a matter of the areas. So I only need to ask 2,000 people in the entire country to figure out what the country's going to do. If you ask the right 2,000 people. Like if you actually have randomly selected 2,000 people across the whole country, that's all I need to figure out how the people are going to go. So like when your TV shows get canceled, that's how they get canceled.
Oh, there's also a very specific reason they don't do internet sweepstakes anymore. This is it.
Yeah, because they're easily hacked and or like done a billion
They
things.
sent people to the Walmart in Kodiak, Alaska, which is the most secluded Walmart in the entire world.
So this is how we got the Hartford Yard Goats, which makes zero sense because they asked the internet. But this is how this type of stuff really does actually impact us, right? This is where this stuff comes up. So we're not going to do the centers of mass, but that's fine. I like this section because it gives you some like internal information. The other one was blood flow through your like arteries and stuff like that. That's all volume. That's the integral volume. It's like you figure out the volume of the thing, you can figure out pressure through it. So it's like those types of things that are also all integration based. They just didn't have any very good problems with that. They wanted you to prove something, and I didn't feel like going through and proving out the formulas. So, yes,
Is this 9.3?
this is 8.3. This will not be on your test. Actually, so what I can't say totally won't be on your test. If there's a question like this on your test, no, it'll be something like this, where you don't need a formula for, but you should realize you can do the integral to find it, like the mosquito problem. Okay?
What do you mean? Like what type of problem do you see?
It'd be like a problem like that. Oh, sorry. It'd be like the mosquito problem, where you don't need a formula for it. You literally just need to know that you can do the integral to find the answer.
But you want to find it?
Yeah, this one you could. This one we did.
Well, yeah.
With Desmos at the last.
Well, no, this one you literally could do out. This one you actually found the integral. You can't find E. E is just a number. E is 2.718. But you can use a calculator to do that. You're just not using a calculator like we did for the probability curve. Yeah.